Hello, dear students. I am Samir Velankar. I welcome all of you to this second video on the topic matrix chain multiplication. In the previous video, we saw what is chain multiplication and what is our aim. We want to multiply the given matrices in least number of multiplications, and we want to find out the best ordering of these matrices. So let's come to this example where we are given four matrices A, B, C, D, and we are asked to find out what should be the order in which these matrices should be multiplied so that the number of multiplications are least. Now, if A, B, C, D are given these four matrices, then the first ordering that you can do is you can take A, B, C, multiply them first, and then whatever is the result, multiply it with D. Or you can multiply AB and the result of AB is multiplied with CD. Or you can first multiply BCD, these three matrices, and then multiply A with the result of BCD. But actually, we can multiply only two matrices at a time. So writing A, B, C together, which I am underlining here, should be elaborated. Now, this A, B, C followed by D can be written in two ways. It can be either first multiply AB, then multiply the result with C. So that is, you are still saying that you will do ABC first. But within ABC, you will be doing AB, multiply A with B, and whatever is the result, you then multiply it with C and finally take the fourth matrix D. Or the other method would be, if you want to do ABC first, which I am again underlining, you can first multiply BC and the result of BC can be multiplied with A, isn't it? But you are still saying that you are going to do ABC operation first. So I am putting this outer bracket and then finally D. So there are two ways in which you can do ABC first and then multiply it with D. Now there is only one way in which you can do this operation: AB first, then CD second, and then multiply AB with CD. It's not very difficult to understand that within BCD here, which I am now underlining, just check this. There are two ways. You can do this by saying first I will do BC and then result will be multiplied with D. Again, we are emphasizing on these parentheses which says that BCD will be done first. Again, the other way is you may say that you will do CD first and then result will be multiplied with B. The parenthesis, the outer parenthesis emphasizes that you are going to find BCD first and then result will be multiplied with A. So there are two combinations, two ways in which you can do this. So in all you can see there are five methods of parenthesizing A, B, C, D. There are five ways in which you can parenthesize A, B, C, D. These are the ways I am numbering, and one of the methods is the best method, the method which will give you the least number of multiplications. Isn't it so? So how do you find out this? As an example, just as an example, how many total multiplications will the first combination require? Just see this. What is the first order? You will first multiply AB, correct? First multiply AB. Check the first order here. First multiply AB. Now, if you multiply A with B, A is having dimension 2 cross 5 and B is having dimension 5 cross 6. So the number of multiplications needed will be 2 multiplied by 5 multiplied by 6. In the earlier video, we saw this. So it will be 2 into 5 into 6, which is 10 into 6, which is 60. So 60 multiplications will be needed just to do A into B, isn't it? But after doing A cross B, you observe that the size of the matrix, the size of the temporary matrix will be 2 cross 6. I hope you are understanding, because A was 2 by 5 and B was 5 by 6. Now this is getting multiplied with C. Check the first combination again. A cross B we have found. Now AB is multiplied with C and C is having dimension 6 by 4. So how many multiplications will be needed to multiply 2 by 6 with 6 by 4? It will be 2 multiplied by 6 multiplied by 4. So it will be 12 into 4, which is 48. So 48 multiplications will be needed to do this ABC operation, isn't it? So 60 plus 48. Till now, number of multiplications are 60 plus 48. But the resultant matrix T again will be 2 cross 4, isn't it? You just check this 2 cross 4. This is the resultant matrix, and this is multiplied with D, last matrix pending, which is 4 by 10. And the number of multiplications needed here will be 2 multiplied by 4, that is 8, multiplied by 10, which is 80. So the number of multiplications needed are 60 plus 48 plus 80. I hope you are understanding. I hope you are understanding. It is 60 plus 48 plus 80, isn't it? So whatever is this number, 60 plus 48 plus 80 multiplications, these are the number of multiplications needed if you use the first combination. But are you sure that this is the minimum number of multiplications? Who knows? The second combination might give the number of multiplications lesser than this, isn't it? This is what we are supposed to find out. I'll erase a few things now. Now, how do you find this? By using dynamic algorithm. What we do is we construct a matrix of size 4 by 4. Here we go. Now we have a matrix. Let's name the matrix as M. And M is a matrix which is 4 by 4. Obviously, because we are given 4 matrices. So we'll take 4 by 4 matrix. We'll take one more matrix N. Usually I like to name this as order, because this is going to give us the final ordering of matrices. So N is an extra matrix I have taken, which is again 4 by 4. Now we will fill this matrix only upper triangle we will fill. We will not fill the lower triangle. You will know the reason ultimately yourselves. So we will fill everything from diagonal upwards. We will not fill anything below the diagonal. So let's try to fill 1 1, M11. Now what does M11 represent is that if you take only first matrix, that is matrix 1 to 1, that's what it says. Matrix 1 to 1 means only A matrix, and you want to multiply. Now there is nothing to multiply if there is only one matrix, and the matrix is 2 by 5. There is nothing to multiply. Then the number of multiplications needed to compute multiplication of all matrices from A to A, that is 1 to 1, is simply 0. Isn't it so? Let's check it again. Let's find out M22. This is again second row, second column, diagonal element, isn't it? So 22 means, M22 means, if we are given matrices from 2 to 2, that is second to second matrix, that means we are given only matrix B and somebody says multiply them. Now come on, you will say there is only one matrix B and there is nothing to multiply. Then in that case, the number of multiplications needed to multiply all matrices from 2 to 2 is 0. Similarly, number of multiplications needed to multiply third matrix, that is only third matrix is given, 3 to 3 is 0 and 4 to 4 is 0. So all the diagonal elements over here are 0. Now let's see what will be M12. Now you just check the order in which we are filling this matrix. That's so important. I'll just draw the matrix again over here for our reference and I'll erase it. Now we are having 4 by 4 matrix, correct? Just sorry for this drawing, but we are having 4 by 4 matrix. Now how we are going to fill this is that we have filled our diagonal elements, isn't it? 1 1 2 2 3 3 4 4. Then we are going to fill 1 2 2 3 and 3 4. Check this, these elements will fill 1 2, then 2 3, and then 3 4. And after filling this, we will fill 1 3, correct, 1 3 and 2 4, these elements, 1 3 and 3 4. And finally we will fill this 1 4. Isn't it so? So we are going diagonally. Every time we take the diagonal of whatever matrix is pending to be filled. So what exactly we are going to now fill? After filling the diagonal elements, check this, we are now going to fill 1 2, M12. So what do you mean by M12? You are given first two matrices, matrix 1 to matrix 2, that is AB. You are given A and B and you are asked to multiply them. And you are asked how many multiplications will be needed. Now, clearly A is 2 by 5 and B is 5 by 6. And remember, you can't do B cross A. You can do only A cross B, because here is the only possibility that number of columns of A matches number of rows of B. So it is 2 into 5. How many multiplications will be needed? It's 2 into 5, that is 10, into 6. Number of multiplications needed will be 60. So M12 is going to be 60. I filled it in the matrix. And N12, I am going to keep it as 1. Now I'll explain this after some time why I am making this entry after filling M12 with 60. I have noted N12 is 1. I'll tell you later why this is 1. Okay. Now which entry will you fill after M12? After M12 we will be filling M23. Just check the direction in which we are coming here. We are filling the matrix in this order. Okay. So M23. Now what do you mean by M23? We are given matrices 2 and 3, isn't it? 2 to 3. 2 to 3 means we are given BC. These two matrices, and we are asked to multiply, but how many multiplications will be needed? This is 5 cross 6 B and C is 6 cross 4. So number of multiplications will be 5 into 6, that is 30. 30 into 4, that is 120. So number of multiplications needed for multiplying 2 to 3 B and C matrix is 120. And I will be writing 2 in N23. I'll tell you later why I am filling this N matrix like this. Okay, next entry that you are going to fill is 3 4, isn't it? Just check. 3 4 means we are given matrices 3 and 4, 3 to 4. That is only C and D. And C is 6 cross 4 and D is 4 cross 10. Then if you multiply these two matrices, how many multiplications will be needed? Is 6 into 4, correct? That is 24. 6 fours are 24 into 10, that is 240. So this element 3 to 4 is going to be 240, and I am going to fill 3 here in the N matrix. N34 is initialized as 3. Okay, now what? Now we are going to go upwards, isn't it, in the diagonal. So now the next entry that will be filled is M13. Now notice here in the matrix M, we are filling M13 and then we will fill M24. Okay. So M13 means what? We are given first three matrices, matrix 1 to matrix 3. I hope you are understanding. That means we are given ABC, three matrices. And we are asked that if you are supposed to multiply ABC, in which order you should multiply. Now you know that there are two orders possible. You can either do AB and then multiply it with C, or you can first do BC and then multiply it with A. These two are the orders. Now starts the fun part. You see, you want to know how many multiplications will be needed for this first combination. Now you don't have to do all the work all over again. But listen, you are going to multiply A with B first, and you already found the answer for this. How many multiplications will be needed for AB is M12. Are you understanding? M12. That's the fun part here, isn't it? Because you have already found this answer. If you are multiplying A with B, then the number of multiplications needed is stored in M12. Now, this is going to be multiplied. So these are the number of multiplications. M12, as you see in the matrix, it is 60. This is going to be multiplied with matrix C. But first of all, how many multiplications will be needed to multiply C? Only C. Only matrix C is given. That is M33, isn't it? C to C. I hope you are understanding. And then whatever is the result of A dot B, you are going to multiply it with C. So how many multiplications will be needed? Listen, A dot B is going to be 2 cross 6 matrix, isn't it? Because A is 2 by 5 and B is 5 by 6. This matrix will be multiplied with C, and C is 6 by 4. So finally you are going to multiply these two matrices, and the number of multiplications needed will be 2 multiplied by 6, that is 12, multiplied by 4, that is 12 fours are 48. I hope you understand. M12, as you see in the matrix, is 60. What is this 60? Number of multiplications needed to compute A into B. Understand that A dot B is 60 multiplications plus number of multiplications needed if only matrix C is given was 0. And then after finding A dot B, you multiplied that A dot B with C. Number of multiplications needed were 48. So this gives you total of 108, if I'm not wrong. Yes, 108 multiplications. And what about A into BC? Now, A into BC can be found by writing A M11. This is number of multiplications only if matrix A is given. What about BC? How will you do this multiplications? We have already found this as A23. Number of multiplications needed to do B cross C is stored in M23, which is 120, plus number of multiplications needed to multiply A with B dot C. Now I'm writing in short here. A is 2 cross 5, correct? And what will be BC? What will be the dimension of BC? After multiplying B and C, you will get dimension of 5 cross 4. Now, then you are multiplying these A and BC, correct or not? Result of BC is getting multiplied. So the number of multiplications will be 2 into 5, that is 10, into 4, that is 40. So this is going to be added with 40. So M11 is 0 plus M23 is 120 plus 40. It is going to give you 160. But you see that you got minimum here as 108. You are saying that if ABC are given, it is better to multiply AB first and then multiply that result with C. So the better answer we got is 108. So I am filling 1 to 3 as 108. And you observe this result 108 we got by doing AB multiplied with C. So the cut was at B. I will write it again here in short. Just check. I am removing this some rough work. How did we get this 108 result? 108 we got for this combination, isn't it? AB multiplied with C. So the cut here was at B, and B is the second matrix. So I am going to put N13. Observe this, the pen where I am writing is 2 because the cut was found at the second matrix. I hope you understand why we are filling the N matrix now. Okay. So 2 or 3 more elements to go. I am just erasing a few things now. M13 is found. And what will be the next value that we are going to find out? The next value that we will be finding out here, after finding M13, we are finding M23, isn't it? No, I'm sorry, M24. Yes, everyone. We are finding M24. This value M24, we are coming diagonally downwards here, isn't it? M24. M24 means what? We are given 3 matrices BCD, 2 to 4, isn't it? BCD is given. Now, what are the possibilities? How you can multiply BCD? There are 2 ways again, isn't it? Of parenthesization. 2 ways are, first, you can do BC, then multiplied with D. Or you can first multiply CD and then take the result and multiply it with B, isn't it? So what is the number of multiplications needed to do BC? It is M23. We have already found out that result, isn't it? Plus, what are the number of multiplications if only matrix D was given? Only D was given. That is M44. That is 0 multiplications. Plus, what is the result to multiply result of BC with D? Now, BC is going to be of dimension 5 cross 4. Because B is 5 cross 6 and C is 6 cross 4. So BC, total result of BC will be 5 cross 4, and this matrix will be multiplied with matrix D, and D is 4 cross 10. So the number of multiplications that will be needed will be 5 into 4, that is 20, into 10, that is 200. So what are the number of multiplications? M23 we have found out in the earlier pass is 120, plus M44 is 0, plus 200. So the total multiplications needed over here will be 320. But we have got another combination BCD. Now, how will you write BCD? This is B is M22 if only matrix B is given, plus CD. To multiply C and D, you already found the answer. It is 3, 4. Correct? And now listen, you are going to multiply B with the result of CD, but B is of dimension 5 cross 6. And CD will be of the dimension 6 cross 10, isn't it? Because C is 6 cross 4 and D is 4 cross 10. So the number of multiplications needed will be 5 into 6, that is 30, into 10, that is 300, isn't it? 300. So the number of multiplications, listen, M22 is anyway 0, 0 plus M34 is 240. We have found that, plus 300, which will be 540. Now, obviously, this 320 is minimum, and you say the best way to multiply BCD is to first take B into C and then multiply it with D. So this element is going to be 320, which we were finding 2 to 4. And where did we find the cut? Now you see this BCD was done as BC multiplied by D. So the cut here was at third matrix, isn't it? C was the third matrix. So I am filling N24, N24 as 3 because the cut was at third matrix. I hope you are understanding. And now coming to our final answer. The final answer over here, trust me, now I am going to tell you the formula, okay? And we are going to try to build the formula. Till now we were manually finding these answers, but just bear with me till I erase the screen. Here we go. Now we are finding final element, the cornermost element in which we are actually interested, which is M14, isn't it? M14. Now M14 is nothing but 4 matrices are given, 1, 2, 3, 4, and we are supposed to find out how many minimum multiplications will be needed. So what are the possibilities? Just check this. We can either take A, B, C, multiply them, and then take D. This is first method. The other method is you can either take A, B first and then multiply it with CD. Correct? And then the third method is you can first take BCD and then result of BCD is multiplied with A. These are the three possibilities. Now you recall, sorry, you recall there were two possibilities in this. Just check this. Just check this. There were two possibilities in the first one, ABC multiplied with D. But I am not writing those two possibilities because we have already done all the hard work of finding how many multiplications are needed to do ABC. We are going to take minimum of these three combinations. I hope you understand, isn't it? Minimum of these three. Now, what are the minimum multiplications needed to do ABC? This is M13. We are slowly deriving the formula, okay? M13. And then only matrix D is M44 plus number of multiplications finally needed to multiply ABC with D. And notice ABC will be of dimension 2 cross 4. Yes, ABC will be 2 cross 4, isn't it? I'll write in rough here. ABC, listen, A is 2 cross 5, B is 5 cross 6, C is 6 cross 4. So after completing ABC multiplication, you will get 2 rows and 4 columns, correct? So ABC will be 2 cross 4. Are you understanding? And you are multiplying this with D, and D is 4 cross 10. So 2 cross 4 multiplied with 4 cross 10, you will get 2 multiplied by 4, that is 8, multiplied by 10, that is 80 multiplications. I hope you are understanding. Just check this again on your own. Okay, what about AB and then CD? This is going to be M12. AB is M12 plus CD is M34. And finally, you are going to multiply AB with CD. But AB is going to be 2 cross 6. Just check the dimensions. AB is 2 cross 6 and CD is 6 cross 10. Result of CD is going to be 6 cross 10. So the number of multiplications needed to do this is 2 into 6, which is 12, into 10, which is 120. So added with 120. Okay. And finally where we are is that we will be having this A, B, C, D, isn't it? Now A is nothing but M11 plus BCD is M24, and finally you are going to multiply A with BCD. Now A is clearly 2 cross 5, correct? And BCD, result of BCD is going to be 5 cross 10. So the number of multiplications will be 2 into 5, which is 10, into 10, which is 100. Now if you compute all this, M13 is going to be 108 plus 0 plus 80. And for the second combination, M12, as you see, M12 is 60 plus 34. 34 is 240 plus 120. M11 here is 0, 24, as you see, is 320, sorry, plus 100. And the minimum over here, needless to say, is 108 plus 80, isn't it? 108 plus 80, correct? Which is 188. I'm not even computing the others, like 60 plus 240 plus 120 and 320 plus 100. And where did you get the cut here? Check, the cut was at third matrix. So I am filling N14 as 3. So how many minimum multiplications will be needed to multiply these 4 matrices is 188. Minimum multiplications needed will be 188. Our cornermost entry has given this result. And now let's see the ordering. How will you get the ordering? Now you observe N14, the other matrix. N14 is 3. That means the first cut you got for ABCD, the first cut you got was at C. That means you are going to do ABC into D. I hope you are understanding. For 1 to 4, for multiplying all matrices from 1 to 4, you got the first cut at 3. That's what you have labeled here, isn't it? Now you watch what is 1 to 3. Observe this ABC, which I am underlining. So you find out what is N13 now. N13. N13, as you see in the table, N table is 2. That means second cut you got at B, correct? So that means you are going to do AB multiplied with C, and of course this result of ABC is going to be multiplied with D. So this is the correct order. I guess you have followed what exactly is this matrix chain multiplication and how we are storing the result and using it in the next pass. Now finally, coming to our algorithm, in our algorithm what we are going to do is these dimensions will be labeled as follows. Check, these dimensions of ABCD will be named by us as D0. This dimension is D0. The next dimension, which is same, is named as D1. This dimension, which is 6, which is same for these two matrices, is D2. The dimension 4, which is same for these two matrices, is D3. And finally, this last 10 is D4. Now we are having 4 matrices, isn't it? And the last dimension we are having is D4. So if D is an array, with 2, 5, 6, 4, 10. See this? This is 0, 1, 2, 3, 4 elements. Then 2 cross 5 is the first matrix. Are you understanding? 2 cross 5. Then 5 cross 6 is the second matrix. 6 cross 4 is the third matrix. And 4 cross 10 is the fourth matrix. This is the way how we are going to store the dimensions of the matrices. In the next video, we will be learning matrix chain multiplication algorithm. Trust me, it is going to be very easy now once you have understood the entire process of matrix chain multiplication using dynamic algorithm. Thank you very much.